Vanakkam. We will learn about addressing modes of 8086 now. The addressing mode is defined as the way in which the data are accessed is described by the addressing mode, which means if you have the data in between the registers, if your process is in between the registers, or if your data in the memory location and the register, or you are addressing the data between the input output devices and the registers, or input output devices and the memory location, or you may have the data in immediately in the instruction itself. So based on all these, the addressing modes are classified. First we will see the register addressing mode. I have taken the first move AL comma BL as my example. So BL is the register what you have, right side is going to be the source always, and the left side what you have is going to be the destination. So always this is a position of destination, this is a position of source, except out instruction. And now I have taken here the BL is a 8-bit register and AL is the 8-bit register. So the size is same, always the size should be same, otherwise it is not possible. Now the BL value is moved to the AL value. So you may have addition, so instead of this data transfer instruction, you can have arithmetic instruction or logic instructions, any kind of instructions you may have. So here BX is a 16-bit register, the value of 16-bit register is moved to the AX 16-bit register, and you can have this kind of example also, but you cannot move or you cannot perform the operation between segment registers. It is not possible. Say an example, say and move code segment comma data segment, it's not possible. Or the segment register, the code segment cannot be, say an example, code segment comma SI. This code segment may not be the destination because we can't change the data often, so because it is stored permanently. What I mean to say, when we embed, okay, that cannot be changed. So here it's not possible, right? So our this is the these are the examples of register addressing mode. And the next we'll see immediate addressing mode. In immediate addressing mode, AM I mean to explain you is addressing mode. So immediate addressing mode, the operand is available in the instruction itself. Say an example, say move AL comma 45. So the AX register in AL we will have this 45. After the execution of this instruction, the 45 data is moved to AL register. Or you may have some 16-bit numbers. Say an example, move AX or BX, any example you can just take. So 1 2 3 4, say hexadecimal, this is an hexadecimal number. So after this the BX register will have 1 2 3 4 as the hexadecimal number. So this kind of thing. So otherwise you can just have like this, say SI comma 5000, the value 5000 is moved to SI, source index register. Now we can see immediate addressing mode is over. No, right? Now direct addressing mode. So third one we can just see as direct addressing mode. So in the direct addressing mode, we will specify the memory location directly. So here say an example, say move AL comma content of 5000. Always it is mentioned with the bracket, square bracket or normal bracket. Okay, both are possible. So here move AL comma 5000 in the sense, so 5000 is the offset address of the memory location. I am not writing the actual address of memory location. So always we specify the offset address of memory location. So 5000 I just have let us example take 61 is my value, that is not 61 hexadecimal. Okay, so hereafter I will not mention H in any number, because all the numbers which we are going to use hereafter in all my videos is going to be hexadecimal. Wherever if I have a decimal, then I will specify it is decimal. So here the 61 is actually moved to AL. So after this execution, this AX register will have the value 61. It's AL, this is AH, AL, AH. So after execution of this instruction, this is source and this is destination. So the value stored in the memory location pointed out by this offset address 5000 is moved to AL. So similarly, very importantly, you need to understand this. So it is say an example AX comma 5000. So both are looking similar, but the register size is different. This is AL, this is AX, this is 8-bit and this one is 16-bit. But now what will happen? Say an example, I have the value 56 in 5000, the value, and the next one I have AD in 5001. So what happens now? Actually, after the execution of this instruction, the values 56 and AD, 56 is moved to AL and AD is moved to AX after this, because here AX is a 16-bit register. So the value pointed out in 5000 memory location as well as 5001 memory location, both are moved to AX register. So you remember, always wherever you see X is a 16-bit operation. So if you have X, the operation is going to be 16-bit. Then for this the opcode is different, for this instruction the opcode is different. So processor will definitely know, which means the circuits are designed based on the opcodes. So there won't be any confusion. So for us, we should not get confused, and if there is any 16-bit representation, definitely two 8-bit numbers will be moved from two consecutive locations, because each and every memory location can hold only 8-bit number. So definitely two locations are required. 5001 we are not specifying in this instruction, so automatically it is moved 5000 as well as 5001, two consecutive locations from the offset address we point out are moved to the register which we given as a destination. Not only data transfer operations, we can have for this any arithmetic or logic operations also. Say an example, add or subtract, anything is possible. Okay, and this is actually called direct addressing mode. Now we'll see register indirect addressing mode. The same, we are going to use a memory location, say register indirect addressing mode. So here actually using the offset address to address the data in the memory location. Say an example here, this can be given as example, say move CX comma say BX. So in this addressing mode, so the offset addresses are holded in the base registers like BP, BX, and then index registers like SI and DI. So these registers mainly used in this register indirect addressing mode. Generally, the general purpose registers you can use your AX and DX and CX also, but for the general instruction, not for the specific instruction. So for some specific instructions only you have to use index registers and base registers. So that difference we need to understand. So here BX is having the value that is actually the offset address of one particular location. So after this execution, after execution of this instruction, say an example, BX is having 4000 4000, and the memory location 4000 is having, say an example, 1 2, and 4001 is having 3 4. These are hexadecimal numbers. Say after execution of this instruction, what happens is, say CX is my destination, right? So this is CL and CH, CL and CH. So after execution of this instruction, what will happen is the 4000 is stored in BX. So now this bracket indicates BX is not a register, this is actually a memory location, the indirect addressing of a memory location. So this becomes a memory location. So it goes to the memory location. This value is moved to CL. So 1 2 is moved to CL, and this value is moved to CH. Always LSB first and then MSB next. So 3 4. So 3 4 1 2 is the data. We have stored it as Actually, it's 1, 2, 3, 4. This is how it is stored. So this is actually moved to CX register. This is the operation performed after this instruction. So if we have move the content of SI, comma, say an example DL. Okay, what happens now? Say an example, I have SI value. I have stored something around 5000, 5000. You can have any number. Should not be like 4000, 5000, 6000. No, no, no. You can have any amount of number, say 123E or 562F, something like that. Any number, because all these addresses are available, and you should know if you are using the trainer kit, then you should know how much memory location they have used as EEPROM. Okay, electrical erasable programmable read-only memory. So that we cannot use. So beyond that, we can use the remaining memory location. So we can use any number provided you know that EEPROM segment. And now for this execution, what really happens? The DL may have, say an example, DL I have something around 05. This 05 is moved to the location 5000, not to the SI register. SI register is having the address, so it is gone to the memory location 5000. So that is the meaning. Understood? So these are the examples of register indirect addressing mode. And one more important thing is this kind of examples, that this kind of instructions are not possible for all the other operations except string. So here this is not possible. So moving directly between the memory locations. So that this other thing. So we will discuss that in interfacing, especially in DMA. And now we'll see the next addressing mode as base plus index addressing mode. So fifth one is going to be base plus index addressing mode. So in base plus index addressing mode, say an example, we can have something like move CX comma BX plus DI. See, instead of having one register, we are having two register. So now what will happen really here is, say, as we have taken like BX is going to be the memory location 4000, and DI is going to be something around 0012, right? These two are the values stored in BX and DI, let us assume. So after execution of this instruction, what happened is, so 4000 4000 will be added with 0012. This becomes 4012, and this is actually memory location, because I told you wherever you see bracket, that's actually memory location, not the data. Okay, so the memory location is pointed out using these registers. The registers does not have a data, the registers have memory location. So 4012 is the memory location. This is having, say an example, FF, and 4013 is 0E. So what happens after this? These are the values I have assumed which are stored in these two memory locations. So after this instruction execution, the CX register is going to have this FF in CL and 0E in CH. So this is going to be the output after this instruction. This is base plus index addressing mode. So here, why we use this kind of addressing mode? So when we have two-dimensional array of data, so this base plus index addressing modes are used. The next we will see register relative addressing mode. Okay, so this the other way of before we go for register relative, the other way of addressing modes are also possible. So here addressing other way of examples, like say base pointer plus destination index comma something like BL in the sense only 1 byte data is moved. BX actually BX in the sense 2 byte data are moved. So it is source and this one is destination. So previously the memory location values are moved to register, so now the register values are moved to the memory location. And you can have arithmetic operations also in this case, or logical operations also. And now sixth one is going to be register relative addressing mode. relative addressing mode. So this register relative addressing mode is similar to base plus index addressing mode and displacement mode. So displacement is nothing but we have a shift instruction, rotate instruction, and those kind of instructions. So there we will have how many times we shift and how many times we rotate, such things. So that is the value, the number what we have in the instruction is actually called displacement. So similarly here it is similar to your the previous fifth addressing mode, base plus index addressing mode. The register relative addressing mode, say an example is move, we can have say randomly x comma say something like di plus 100. Okay, so 100 in the sense 0 1 0 0, or we can just have 2-digit addresses too. Okay, so here this is the example. Say for avoiding confusion, we are not going to use such huge data, so I just going to have 05. Okay, it's an hexadecimal. So number fine. So now instead of having a register, we are having the data. So this is the displacement, right? So this is called base, that register relative addressing mode, simply register relative addressing mode. So here also this following registers, this base pointer, bx register, destination index, source index, these are the registers are used for this addressing mode. Then next we can have as string addressing mode. In the string addressing mode, the examples are move, mov sb, mov sw, move string byte, move string word, such things. Okay, so here mainly source index and destination index are used, which means say source index is having say an example 4000, and then destination index is having an example as 4100, and this have number 11. And what happens, move string byte, it actually moves the value of 11 to, after execution of this instruction, value of 11. See here we don't specify si and di and all, but directly this has to be defined in the previous instruction. So we move, after the execution of this instruction, the 11 is moved to 4100. This is what happens in the string addressing mode. If it is movsw, then 2 bytes are moved. So here we use index registers. So next we will see base relative plus index addressing mode. So the eighth one, so 7 is over. Okay, eighth one, so we will have base relative plus index addressing mode. So here it is a combination of the previous two, that is not string, the sixth one and fifth one, the register relative as well as base plus index addressing mode. So now say an example, simply we will have move dh comma say base register bx plus index plus displacement. What happens now is, so this is bx plus, fine. So this bx value is added with the dx, and dx the sum of both is added with this 20, and now we actually get the actual address. That actual address value is moved to dh. So this is destination. So to find the one particular address, we actually sum 3 different numbers from 2 registers and 1 immediate value. So this is actually called base relative plus index addressing mode. This kind of addressing mode is also used when we have huge or matrix amount of matrix type of data. And then now we'll see implied addressing mode. In implied addressing mode, actually here the operand is specified in the instruction itself. Say an example, say stc set carry, clc clear carry, std set direction flag, cld clear direction flag. These are 1 byte instruction which are actually used to do a particular task like this. So these are next you have some many things, as we have halt, such things are implied addressing mode. And now we will see direct IO port addressing. So only two instructions are available, direct or IO port, direct or indirect IO port addressing, IO port addressing mode. So in this we have only two things as example. One is in instruction, other one is out instruction. So in instruction we have either in IO mapped IO or input output mapped input output addressing method, or memory mapped IO, which means the input output devices can be addressed by only 2-digit hexadecimal 00 to FF, totally 256. So 256 input output devices can be attached with the use of interfaces, okay, based on either serial, whether it is serial or parallel devices. And or otherwise you can have a memory location to address the input output devices. Say an example, the memory location we give offset addresses from 4 zeros to 4F. These memory locations can be used to just address the input output devices. So here it is 64K offset. Okay, so this many number of devices can be attached, but with huge amount of interfaces. So this is called memory mapped IO and IO mapped IO. So here we'll see this example, like say AL comma 06, which means 06 is not a data. Okay, 06 is the address of a device. Okay, this is port address. Okay, so port address. So this port address, in this port address an input device is connected, because we use in instruction, input device is connected. So from that device a data is moved, that is 1 byte data is moved to AL register. That is the function of this instruction. Say an example now, next we will see. So DX comma AX. So what happens in this? Here DX is a register that has a offset address, that we know that offset address is not the address of memory location. That, say an example, now so DX is having say 1000. So this 1000 is not memory location, it is a address of an output device, because we use out instruction. We need to use out instruction to send data to the output device, right? So this is actually not data or the address of memory location, it is the output device address. So the AX is a 16-bit register. So here the 16-bit values are moved from AX register to the output device addressed by DX. This is memory mapped IO. Okay, so this is how the addressing modes are classified. In next video we will see how to write or how to start learning, or how to learn to write assembly language program from the scratch, from the beginning. So what are the various methods to write assembly language program, right? I hope you have understood this addressing mode. Thank you.